Dr. J. Somashekar received his PhD degree in Computer Science and Engineering from JNTUA, Andhra Pradesh in 2017 and MTech degree from the NIT Surathkal in 2010. He is currently working as a professor and head of the department at Computer Science and Engineering Department, Gopalan College of Engineering and Management, Bangalore. He has completed 80 AICT FDPs, ISTE FDPs, STTPs, guest lectures or national webinar sessions in 10 states of the country and 3 international events. He got All India rank of 43 in the GATE examination with 98.4 percentile. He has more than 14 years of experience in teaching and 6 years of experience in research. He has published 23 research articles in the leading journals and 2 international textbook chapters. He has 157 citations with an H-index of 7 for his research publications. He is the reviewer for reputed international conferences and session chairs for 3 international conferences and guest editor for 3 journals. He is also a visiting professor for data science PG course at Government University, Kerala. Currently, he is guiding 2 PhD students under BTU. With immense pleasure, we welcome you, sir, to this session. Please start your session now.
Thank you, ma'am.
Over to you.
Yeah, thank you. Thank you for introduction, ma'am. Thank you, sir, for opportunity. So, good morning to all the participants. Coming to today's session, in-depth intuition of Navier-based classifier in machine learning and its applications. So, we are going to discuss how to derive Navier-based classifier in machine learning by using Bayes' theorem. So, in-depth intuition, because in general, wherever if you may refer materials or maybe videos, we used to find direct formula and how to apply that formula to the data set, and based on that, how to do classification. Most of the resources you can find this data, but in this today's session, I will show from basic probability to Navier-based classifier how we are going to derive, and by using that what we are going to do or what are the applications with that. I will show some of the data sets with a case study type, and we will see how it is applicable for classification of the data. It's an interesting topic only because we have used number of applications in various sectors, so that we'll discuss in detail in today's session. So whatever we are going to derive this classifier mathematical intuition, this is not only useful for some like healthcare or maybe cyber security. We have whatever application if we take same concept, only thing is the data set is different. We have to change the data set and we have to apply same classifier, and you can go for a classification accuracy. So that's why it's very, very useful for entire data sciences. Of course, machine learning is a component of data science that everyone knows. Now, first we will see what is the agenda of today's session, so that you can get idea what we are going to discuss in today's 1.5 hour session. Of course, it will take more time, but I will try to concise as a 1.5 hour session. In that session, you can understand exactly the intuition followed by applications of Navier-based classifier with basic idea of Bayes' theorem in the probability. So first we'll discuss machine learning basics. What is machine learning, and what is the machine learning models, and what is the difference between traditional programming and machine learning. And next we will see Bayes' theorem, that most of the participants studied in lower classes Bayes' theorem, so that we will see how we have to derive. By using that, how we are going to derive Bayes in classifier or Bayes classifier. By using that, we are going to see various applications that is called Bayes classifier applications. We will discuss in detail, so that you can understand the significance of Bayes classifier for real world problems followed by solution. And also we will see some of the case studies of Bayes classifier, how we are applying Bayes classifier for healthcare sector or cyber security, or maybe other applications, or maybe other sectors that we will see in detail, so that you can understand the significance. And also I will show some of the resources, because what we are going to discuss that we can find still more details about other classifiers under supervised learning in machine learning. So that materials I will show, so that you can extend or you can enhance this concept in future for your publications, or maybe for your research, or maybe for teaching purpose. That depends on the interest of the participants. So this is a brief agenda of today's session, and we will see one by one, so that you can understand exactly the concepts what we discussed in the agenda. So first we'll see what is machine learning. Of course, machine learning is a component of data science. So, but what is machine learning? Whenever if I take human, so we can learn from based on the experiences, but how machine will learn? Of course, so machine also can learn based on the first data with the help of some machine learning models or algorithms. So that is the basic machine learning concept. So by using machine learning, we can extract insights of the data. Based on that, so we can make prediction or forecasting. The objective of data science is to make a product. Whatever data we have, by using that data we have to make a product. That is the main objective of data science. That's why nowadays we have huge demand for data scientists. Suppose if we have healthcare data, let us assume COVID-19 data, based on that we have to make a product in such a way that that product will predict whether the person having COVID-19 disease or not. Or maybe I have a data regarding let us assume recommendation. Based on that I have to make a product. By using that product I can recommend movies, I can recommend music, I can recommend products to the customers. So that is the basic idea of data science, in which machine learning is one of the component. By using this machine learning we can extract knowledge or pattern from the data. That is called insights of the data. Based on that we can go for prediction or classification. So it depends on the application. We can go for either prediction or classification, that we will discuss in detail in today's session. But here data is very, very important. Without data, nothing to do with machine learning models. Suppose I don't have any data, but I know all the machine learning models, but there is no use. What we can do with machine learning models without data? Because we are running in big data era. So everywhere we have huge data. If we take colleges or companies or industries or organizations or universities, wherever if we take, we have huge data, but we have to do some process with that data. For that only machine learning, data science, artificial intelligence, natural language processing, deep learning, all those things comes to the picture. And there is a huge demand for these courses also nowadays, because there are huge number of vacancies are available for this special data scientist or maybe machine learning experts. So that's why we have so many courses nowadays introduced this machine learning also, or data science. So that means the basic idea of machine learning is to extract knowledge from the data. Based on that we can predict our classification. So what does it mean? If we take, let us assume, so let us assume day and number of COVID cases. So 1, 2, 3. 3 days we have number of COVID cases 10, 5, 10, let us assume 14. So this is the data I have. So by using this data, we can make a model. Let us assume regression, y equal to linear regression 2x plus 4. This is the model, or we can call it as a program. So by using this model, so we can predict how many number of COVID cases in 4th day. Let us assume here 17 I can predict. This is the basic idea. So we have to make a model. Based on that model we can forecast or we can predict the future value. But here data is very, very important. Based on this data only we are making this model. So that's why, so because this why we have to go, why can't we go program, will get doubt, because we can't explicitly write program for this type of data. Like sum of two numbers, anyone can write program. Multiplication of two numbers or roots of quadratic equation, explicitly we can write program for such type of data. But if you take this type of data set, it's very difficult to write explicit program. That's why, so we have to make a model based on that data. By using that model we can predict the future value. So this is one of the simple example for prediction of number of COVID cases. So for that we have to make a linear regression or maybe any type of regression. By substituting x value, we can find the value of dependent variable, that we can call it as a y here. Now here you will get doubt why it is different from basic programming and traditional programming, I mean machine learning. So whenever if I take traditional programming, let us assume if we take C equal to A plus B, suppose if I want to write a C program, so I have to declare main function, variable declaration, and statement C equal to A plus B, print the value, and scan also we have to take. So that means data we have to give. First we have to write a program, sum of two numbers. After that we have to give data. Let us assume A value, B value. A is 5, let us assume B is 4. After that it will generate an output that is called 9, 5 plus 9. This is the traditional programming. So sum of two numbers, or maybe the roots of the quadratic equation, multiplication, whatever it may be. So we have to write a program. After that we have to give input to the variables, let us assume A comma B. Then after that when you execute the program, you will get output that is called 9. This is the traditional programming. But when you come to the machine learning, what happens? We can't write explicit program for some of the applications or maybe some of the data. Let us assume if we take traffic prediction, or maybe if you go for recommendation, or if you want to go for healthcare prediction, that means diagnosis. For that we can't write explicit program. Based on that we can't go for prediction. So directly how can I write program? If you have this symptom you'll get COVID-19, I can't write exact program. So if you write like that, then machine learning is not required. That's why, so we have, based on the history and based on that we can make a model, then we can predict whether the person having COVID-19 or not based on the symptoms. So that's why here we can't write explicit program. That's why we have to go for machine learning. So here what happens, so we have a data, we have output also. That is the beauty here. We have a data and we have output. After compiling, it will make a program, or we can call it as a model. So by using this model, we can predict the future value. Whatever program or model or function, for that we have to give input so that it will predict how many number of COVID cases tomorrow, whether the person having COVID disease or not. Like that we can predict. So still if you are not able to understand, I will show one of the simple data set we can understand here. This is the COVID-19 synthetic data set. Here we have patient ID, and this is called futures, or we can call it as a patient health record. Each patient having symptoms, we can call it as a futures in the machine learning technically. So let us assume like pain, headache, like that. This is called input, and this is the output. Class is nothing but output. So that means both we are giving to the system. So by using this we can make a model. So what is the output? Or we can call it as a class, or we can call it as a label, or we can call it as a supervision. There are so many synonyms for this class, output, whatever it may be. So this data we have to give, we have to make a model by using this data. Let us assume the model is, let us assume y equal to f of x. For simple terms I am explaining. So model we got, or maybe y equal to f of x1, x2, so on, xn. This is the model. And one active patient visited the doctor, or maybe one active patient symptoms I know. So x1 is chest pain, x2 is dry cough, x3 is loss of speech. So once if we give these features, or we can call it as a symptoms, then y equal to, you will get output, this person having COVID positive, or this person having COVID negative. This is the meaning of output, model or program. So y equal to f of x, the function, when you give x1, x2, x3 values, that is the symptoms of the active patient or new patient, we can predict the person having COVID positive or negative. So how we have to make this function f of x? We are not writing any explicit program, but based on the data available, already 9 patients we have in this synthetic data set. Based on that, I have to make a model, or maybe function, or maybe program, whatever name you can assume. That's not an issue. So based on that, we can predict the future value. Now I think it's clear. So what is the difference between traditional programming and machine learning? So that's why in machine learning, data, that means symptoms or maybe futures, and output, that is called class. So this is available already. Based on that, we can make a program or maybe a model. By using that, we can predict or we can forecast the future value. I think it's clear what is machine learning now. That's why based on the data, we are not writing any explicit program. By using some of the statistical tools, based on that, we can make a model. Hence, we can predict the future value. So that is the basic difference between traditional programming and machine learning. So now we have a big data era. Because of that reason, machine learning comes to the picture, and we have huge number of applications in the real world problems. And here we can see the basic machine learning model. We have a data set, and training data you can assume, let us assume 80%. Test data you can assume 20%, or 70-30, depends on the convenience. So 80%, let us assume training data set. So training is, just now I have shown one of the synthetic data set. So that data we have to train. Based on that, it will make a model. And for this model, we have to give tested data. Why we have to test? Whether the model will predict perfectly or not. So for that, we have to evaluate the accuracy. Once the accuracy is good, then we can deploy to the application. For example, the synthetic data set of COVID-19 just now have shown. So if we consider that data, so we have to make a model, then we have to give the test data. Then once the accuracy is, let us assume 99% or 95%, depends on the threshold what we are going to fix for the application, we can deploy. Suppose the accuracy is, let us assume 70%. This is not that much increasable accuracy, so we are not going to deploy to the application. That means we are not going to deploy this model to the healthcare sector for detecting COVID-19 or not. Not only for health sector, maybe other applications also we can consider as it is. So that's why here accuracy is very, very important. Whenever if I go for machine learning model, first we have to train, After that, we have to test. After that, we have to see accuracy. Once accuracy is very good, then we can deploy to the application. That's why without accuracy, we can't deploy to the application. If it is so, then there is a big issue in future. Suppose the model is good, okay. If the model is wrong, then what happens? Instead of COVID positive, it will detect COVID negative. Instead of COVID negative, it will detect COVID positive. Then there is a huge problem. Because of that reason, before deploy to the application, or maybe healthcare sector, or maybe any other domains, we have to check the accuracy. That's why in machine learning model, we have to take training data and test data, then we have to look for all these aspects. That is the basic machine learning model. And here we have various type of classification problems. So supervised learning, unsupervised learning, semi-supervised. So of course, this is very huge topic to explain all those things. Just I'm giving brief idea because we are focusing on supervised learning. For that, I'm showing this table in brief so that you can understand. But when you go for inside just classification only, I can go for 1 hour also. What is classification? What are the types of classification? What are the mathematical models? Or how the function is useful to make supervised learning model? Like that, we have so many other concepts. But for the sake of intuition of Bayesian classifier, just I'm showing what is supervised, what is unsupervised, and what is the combination that is called semi-supervised. In supervised, we have labeled data. That means we have symptoms of the patient as well as the disease, whether the person having positive or negative. So this is called supervised learning model. Based on that, we can make a model, and hence we can predict the future value. So when you go for unsupervised learning, we don't have any label. That means it is unlabeled data. By using that, we can make a model. Based on that, we have to predict the future value. So here we have to look for a distance measure, or we have to look for the futures, all those things. So, but we are not going to focus on unsupervised, like we have clustering algorithms, or maybe we have other classification algorithms under unsupervised learning. Based on that, we can do for unlabeled data. So even association rules also comes under unsupervised learning, but we are not focusing unsupervised. We are focusing only for supervised. Suppose if someone will ask what is semi-supervised, it's a combination of both. So some data having labeled data, some data having unlabeled. It's a combination of labeled and unlabeled. That means labeled data union unlabeled data. That is called semi-supervised learning model. So, but basically the supervised learning models having classification and regression. So, and when you come to the Bayesian classifier comes under classification, that's why we are focusing only for supervised learning model. That means we are taking a data set which is having labels. That means labeled data set we are going to consider for various applications by using Bayesian classifier. So here I already said, so we have basically under supervised regression and classification. Classification means whenever if I receive a mail, I have to classify. So just we have to make category, the mail is spam or not spam. Whenever if we receive some data, so we have to classify that data is good or bad. Whenever if I receive a student percentage, I have to classify the student got distinction or first class. Or whenever if we take student percentages or marks, I have to classify pass or fail. Like that binary classification, or we can go for categorical classification. For example, type of cancer disease. We have various type of cancer diseases like skin cancer, maybe a brain cancer, or maybe other type of cancers. Like that, we have to go for categorical classification. So depends on the application. We can go for either binary classification, or we can go for categorical classification by using various machine learning models. So regression means this is applicable to continuous data, especially for forecasting, weather forecasting, or number of COVID cases prediction. So for that, we have to go for regression, but this is out of scope for our session. We are focusing only for classification, in which we are going to focus on Bayesian classifier. By using that, how we are going to classify. So these are the applications of machine learning. So medical diagnosis, we will see examples by using Bayesian classifier also. And online fraud detection, we can apply Bayesian classifier. Email spam, this also I will show one of the example how to do email spam by using Bayesian classifier. Even product recommendation also we can do by using Bayesian classifier. So this case study I'm not going to discuss today. I think one more section I have maybe later. So on that day, I will discuss this case studies of product recommendation and credit card fraud detection and forecasting by using regression models or maybe time series data At that time, I will discuss in detail of various case studies, but strictly we are focusing today on Bayesian classifier application. And traffic prediction we can use forecasting. So but we are not going to discuss these things. We are focusing more on medical diagnosis, email spam detection, etc., by using Bayesian classifier applications, and with some of the data sets examples also I will show, so that we can understand exactly. So this is the, so far we discussed the machine learning introduction. What is machine learning? What is the difference between traditional programming and machine learning? What are the applications of machine learning? And what is machine learning model? And what are the various type of classification problems like supervised, unsupervised, and semi-supervised? And now we will see the main scope of our session. What is Naive-based classifier, intuition, and by using that, how we are going to apply for various data sets and what are the applications. So this Bayes theorem proposed in 1970s. So that means after 300 years still we are using this Bayes theorem for our applications in machine learning. So you can understand in detail what is Bayes theorem, all those things. Based on that, how we are going to discuss, or how we are going to derive Bayes classifier for our various applications. So first we should know basic probability. After that we'll go for derivation of Bayes theorem. So here I will show, of course most of them knows basic probability. Just I'll give introduction. After that I'll move to the directly the derivation of Bayes theorem, followed by classifier, followed by applications and with case studies. So the basic idea of probability is possibility. What is the possibility of getting rain tomorrow? 80% means, so 0.8 is the probability. Suppose I will get, what is the probability of getting rain tomorrow? The probability is 0.8. So that means 80% possibility is there. Or what is the probability that a student will pass in the examination? Probability is 0.3, 30% possibility is there. So it is basically the possibility, or we are looking for what is the possibility that the event going to happen. That is the probability. Or maybe in election time also we used to conduct survey. The probability of X party going to win in this elections is 0.8, 80%. The probability of Y party is going to win in this election 1 probability, let us assume. So 100% possibility. Just possibility only. Based on that we can't say why not happen. Probability is 1, but why not happen, like that we can't. Just we are looking for possibility. So because in machine learning also we are looking for prediction or maybe classification. So that's why probability comes to the picture, and it's very, very important for machine learning models also. Now the possibility of any sample space, let us assume, I am assuming sample space for student marks, let us assume 50, these are the marks I am assuming, 50, let us assume 30, let us assume 60, let us assume 85. So, or maybe one more data, I am assuming 90. So these are the marks of the student, that is called sample space. So marks of 5 students here. So the probability of a randomly selected student will pass in the exam. Probability of pass. I want to find what is the possibility. In that case, the basic probability is favorable number of cases, total number of sample points, or exhaustive number of cases. So how many total number of sample points we have, or total number of students we have? So we have 5 students. So n equal to 5. Number of students passed in the exam. So minimum 35. So 50, 60, 85, 90. So that means 4 students. So 4 by 5. So this is the probability that a randomly selected student will pass in the exam. This is just a possibility only, around 90%. So possibility, or maybe 80% possibility is there. So this is the basic idea. Or maybe what is the probability that a person having COVID positive disease? So COVID positive. So in that case, let us assume the probability is 0.9, 90% possibility is there. So this is the basic idea of probability. That means favorable number of cases divided by total number of cases, that leads to the basic probability definition. Now here, whenever if I take some of the application, this basic probability won't give more accurate results. That's why we have to go for conditional probability. For example, if you take here, you can see probability of a COVID disease possibility is 0.9. But here we don't know what are the symptoms of this patient. If you know symptoms, we can say exactly this is the possibility. Then that is more accurate than without symptoms. So that's why what we have to do is we have to go for conditional probability. So probability of a person having COVID, given that what are the symptoms he is having, let us assume fever, let us assume dry cough, let us assume breathing issue, let us assume these are the symptoms I am assuming. So then the probability of a person having COVID given is having symptoms, fever, dry cough, shortness of breath. So the possibility is 0.95. That means 95% possibility is there. So this is more accurate when compared to the basic probability. Why? In basic probability, I don't know what symptoms I have considered. I don't know anything about symptoms, but simply I'm telling is having 90% possibility of COVID-19. So which is not that much accurate when compared to the condition. But here we have condition. Is having fever, is having dry cough, is having shortness of breath. Based on that, I predicted or I calculated the probability is 0.95. So that means 95% possibility is there is having COVID positive. So that means the basic idea is, so this is the condition. The futures or symptoms is nothing but condition. Based on this condition, we are predicting the person having COVID-19 or not. So this is the basic idea. Remember, this basic idea tends to end of the session. All the concepts we are going to use by using this basic conditional probability. So the probability of COVID given symptoms or futures, technically we can call it as a futures. So based on that, we are going to find person having positive or negative. That means mathematically we can write, so probability of, let us assume class C. The class may be positive or negative given. So what are the symptoms I am taking? X1, X2, so on, Xn. These are the symptoms or futures of the given data. For that, we have to calculate the probability. So, for example, again, let us assume if C is plus, that means positive COVID, the probability is 0.8. Suppose if C is negative for the given symptoms, the probability is 0.2. So 20% for probability for a negative COVID, 80% possibility for positive COVID based on the symptoms X1, X2, Xn. X1 means fever, X2 means leg pain, X3 means shortness of breath, X4 means let us assume cough. That is the meaning here. So that means here based on the symptoms, I got a probability more for positive disease. Hence we can say the given person having COVID positive. This is the basic idea what we are going to apply for all the applications, not only for healthcare, even if you take cyber security application, or if you take recommender system, or if you take any other applications also, we are going to apply basic idea is this one only. So we have a symptoms features. Based on that, we are going to find the probability that a person, not only for binary classification, you can go for categorical classification. So if we take C is C1, C2, we can call it as a binary classification because we have two classes only, like positive or negative. Suppose if we take C equal to, let us assume C1, C2, C3, C4, let us assume type of cancer. It may be brain cancer, or maybe stomach cancer, or maybe skin cancer, or maybe leg cancer. So in that case, we can call it as a categorical classification. This is categorical classification and this is binary classification. Binary means true or false. So categorical classification means any value it may take. So it may be 2, or it may be 3, or it may be 4, it may be 100 also. So it depends on the number of categories here. I think it's clear the basic idea of basic probability and conditional probability. So here the formula for conditional probability is P of A given B equal to, so P of A intersection B divided by P of B. So this is the basic formula for conditional probability. This we are going to apply for deriving the Bayes theorem. So P of A intersection B divided by P of B. So why we have to consider this formula? So the basic idea beyond this formula I will explain through Venn diagram. So this is a Venn diagram, and where I am assuming this is A and this is B. I am assuming two sets, and which is nothing but intersection, that is the common area. And here you can see, so B is the condition, that means symptoms of the patient. So entire B we have to consider. In entire B, A is nothing but class, let us assume positive or negative, in which the possibility of getting positive we have to find. That's why, so numerator is P of A intersection B. Entire B, that means all the symptoms whatever patient having, in which positive, whenever if you take these symptoms, the probability of getting positive means intersection. So that means P of A intersection is the numerator, and entire B is nothing but denominator. That sample space is nothing but entire B, not A union B, just B, because we are looking for based on the symptoms what we collected from the patient. Based on that only we are looking for whether the person having positive or negative report of COVID. So that's why we have to consider entire B is nothing but denominator. So that means favorable number of cases is nothing but intersection, exhaustive number of cases is nothing but entire B. So that's why we derived P of A given B equal to P of A intersection by P of B. In general we used to by heart, but this is the basic idea through Venn diagram. Now I think it's clear what is basic probability, what is conditional probability, what is the formula for conditional probability. Now we will see how to derive Bayes theorem, followed by Bayes and classifier, followed by examples and applications. So we know conditional probability for A given B. So P of A given B equal to P of A intersection by P of B. Just now I explained through Venn diagram also. If any doubt also you can ask me, please unmute. And the next one is the conditional probability B given A. So P of B, denominator only changing. So denominator means the condition is nothing but exhaustive cases, exhaustive number of cases. That's why it comes to the denominator. Here the condition is nothing but exhaustive number of cases. That's why it's coming to the denominator P of B, here P of A. Now it's fine. We know conditional probability for A given B, and we know conditional probability for B given A. These two formulas we know how to write and how to derive also. Now we know basic idea. A union B is same as B union A. So this is the basic idea that we studied in the 7th class or 8th class in the sets. So A union B is same as B union A. Of course, this is clear or trivial. And in similar way, A intersection B is same as B intersection A. So this is also basic idea only. So A intersection B is same as B intersection A. So now based on this basic idea, we can write P of A intersection B equal to P of B intersection A. I think there is no doubt here. So why A intersection B is same as B intersection A? So that's why we are writing P of A intersection B is same as P of B intersection A. Now from the first equation, we can cross multiply, which leads to P of A given B. We can read it like this: P of A given B, bar means given B, into P of B. How we got this one? From the first equation. Let us assume I can make it as a label 1 and I can make it as a label 2. From label 1, we can cross multiply so that we get P of A intersection B equal to P of A given B into P of B. In similar fashion, we can write from the second equation P of B given A equal to P of B intersection A by P of A. Just cross multiply, we will get this one. So finally, P of A given B equal to this one. This is called Bayes theorem. So here A is nothing but what we are looking, and that means class here. If we are talking about machine learning, A is nothing but class. It may be C1, C2 when you are talking about binary classification, or C1, C2, C3, so on if you are talking about categorical classification. So B is nothing but condition. Whatever conditions we have, that means symptoms of the patients or features of the given data, equal to P of A. So probability of an event A, and this is called prior probability. P of B given A, this is called likelihood, and P of B, this is called evidence, and this is called posterior probability. The terms not required, no need to understand in depth what is evidence, all those things. Just I'm telling, but this formula is sufficient for classifier. This is called Bayes theorem. We can call it as a Bayes theorem. P of A given B equal to P of A, that numerator as it is, that is called prior probability, and this is called likelihood. P of B given A, that is called likelihood, divided by P of B, that is called evidence. Evidence is nothing but all the symptoms we are going to consider. Based on that symptoms of the patient only, we are going to find the probability whether the person having disease or not. So this is a Bayes theorem. I think it's clear. We know what is basic probability, we know what is conditional probability, and based on conditional probability, we derived the Bayes theorem. Now, by using this Bayes theorem, how we are going to apply to the given data set? That is the question here. We can see the data set looks like this for supervised learning. So we have various symptoms, or we can call it as a futures. These are the futures: x1, x2, x3, xn, and the class that is called output. Let us assume R1 is nothing but patient 1. Let us assume. So x1 means, so let us assume fever. x2 means cough, maybe shortness of breath. xn means, let us assume, leg pain. So these are the futures available. Let us assume 1 means the future is available, 0 means the future is not available for the patient P1. And the class is available: this person having COVID positive, this person having COVID negative, this person having COVID positive, like that. The class of each patient is available, P1, P2, like that. Now the question is how we are going to apply for our Bayes theorem to this data set. So the data set is clear because we are talking about supervised learning. There we have a set of futures or symptoms, and also we have supervision, or we can call it as a class, or we can call it as a label. Everything is available. The question is how we are going to apply Bayes theorem to the given data set. This R1, R2, so on, we can call it as a records or sample points or samples. And the columns are nothing but futures or symptoms, or we can call it as attributes. Now, how we are going to apply our Bayes theorem to the given data set? That's the main question. Now we will see the solution, that is called Naive-Bayes classifier. We are going to derive, that is called intuition. Based on that, we will see how we are going to apply to the data set. So here we have a little bit mathematics. So try to understand. Any doubt also you can stop and you can ask me, not an issue. So we have Bayes theorem, it's clear. I derived just now. B of A given B equal to P of A into P of B given A by. This is called posterior probability. That means what we are looking, and this is the evidence, that is called futures of the patient, and this is likelihood. That means what we are going to extract a future from the given data, and this is the clear probability, that probability of positive, negative, that probability is nothing but clear probability. That we know already, data is available, that's why we can call it as a clear probability. Now we are going to apply data set to this Bayes theorem, or how we are applying Bayes theorem to our data set. Now here P of A, here A is nothing but class. So let us assume here A is nothing but class, let us assume Y. So this Y could be either C1 or C2 or C3. Let us assume I'm talking about binary classification, C1, C2. So try to understand. So this Y is C1, C2. So when you are talking about binary classification, or maybe C1, C2, C3, so on, if you are talking about categorical classification, this is fine. And B is nothing but the futures or attributes. So this is nothing but future vector. So we can call it as a X1 symptoms, what we can call it as for healthcare data, X3, so on, Xn. This is called capital B. So we can call it as a capital X. So this is capital Y. So in place of here, we are assuming capital Y, that is called class. In place of B, we are assuming futures or symptoms or attribute, that is called capital X. So now we are going to replace. So this X is nothing but here capital B, that is the condition, that is called evidence. We can call it as evidence. And Y is nothing but capital A. So it can be either binary values or it can be categorical values like C1, C2, so on, Cn. So depends on the application. Now just I am replacing these values in the Bayes theorem. So P of Y given X. So just I am replacing the data in the Bayes theorem. P of Y given X. Y is nothing but A, X is nothing but B. And Y given, X means X1, X2, so on, Xn. Now right hand side, P of A. P of A means P of Y. This we can replace it by P of Y. And P of B given A. So B means X1, X2, so on, Xn. That's why we can write it as X1 given Y into X2 given Y into Xn given Y. I'm talking about right side of the Bayes theorem. Divided by P of B. What is B here? X1, X2, so on, Xn. That's why we can write it as a P of X1, X2, so on, Xn. Now we will get doubt. How? Because P of B is nothing but P of X1, X2, so on, Xn. How can you write P of X1, P of X2, Xn? Here we have an important point. The Nave-Bayes theorem always depends on the assumption that the futures or attributes are always independent. So that assumption is very, very important. That means whatever symptoms we are considering, let us assume dry cough and fever, or maybe leg pain or shortness of breath. We have to assume all these are independent. So that means the futures or the symptoms what we collected from the data, these are all independent in nature. So that's why in probability we have one concept that is called independent events. Whenever two events are independent, let us assume X and Y or A and B, we can write P of X intersection Y equal to, we can write it as P of X into P of Y. That means P of X means independent probabilities of X into Y. So, or we can write it as, so P of X1, X2 can be written as X1 comma X2 can be, instead of intersection, I can write simply X1, X2 also. So P of X1 into P of X2. So this is the main assumption what we are doing here. In the Nave-Bayes classifier, having main assumption, all the futures or symptoms we are considering are independent in nature. So because of that reason only, numerator can be written as P of X1 given by X2 given by Xn given by, denominator P of X1, P of X2. Otherwise we have to write P of X1, X2, so on, Xn. So in that case, we have to go for something joint probability. I think it's very difficult. I did not see so far how to apply if the independent assumption you are not going to consider for Bayes theorem. So that's why here we are assuming independent in nature. I think this step is clear. So this one step only we have to recollect so many concepts in probability. So this is clear. Now this can be written as, so probability of Y into product. We can write product P of Xi given by I varies from 1 to n. So no need to specify explicitly. Understood that? So this entire thing we can write it as a product of P of Xi given by divided by P of X1, X2, so on, P of Xn. So this is P of Y given X. So now here what happens? Whatever Y value if we take, we can take either class C1 that means COVID positive, or if we take class due to COVID negative, there is no change in the denominator. You can see the beauty here. Whenever if I take y value, either C1, C2 or C1, C2, C3, whatever it may be binary values or categorical values, whatever data if you are considering as a numerator, that is y value, the denominator won't change, that is constant. So you can see here right side, so you can see the reason here. When you take C1 class, given the future x, denominator is same. When you take C2, denominator is same. When you take C3, the denominator is same. That means in all the cases, the denominator is constant. Because of that reason, we are not going to consider for further step. What does it mean? For example, if you want to understand clearly, if we take 2 by 3, let us assume 1 by 3. So obviously 2 by 3 is more than 1 by 3. So 2 by 3 greater than 1 by 3. If you want to compare these two values, 2 by 3 is more than 1 by 3. But denominator is constant. If you remove denominator, we will get 2, here 1. In this scenario also, 2 greater than 1. The property is same. Maybe we are removing denominator, but the property is same. So because of that reason, we are removing denominator. Unnecessarily, we will get more computations while writing program, that we can call it as a time complexity, space complexity. Unnecessarily, we are giving more time complexity. That means instead of 2 seconds, it will take 5 seconds for executing the entire data set or compiling the entire data set. Because of that reason, we are straight away removing denominator. So it leads to P of y given x equal to P of y into product of P of xi given y. So this is the final P of y given x. Now what is the final classifier? I think this slide is clear. So final classifier is we have to find the maximum probability. From that we are looking for classification, or from that we are looking for the class. So now up to here clear. Still one more step left that we will finish. Now we know what is Bayes theorem and how we are going to apply to the data set. What we consider here, you can see the data set here. The data set for supervised learning looks like this. All the attributes followed by class, we can call it as outcome. And this we are going to apply for our Bayes theorem. And finally, we got P of y given x. Y is nothing but class. What we are looking, x is nothing but futures or attributes. That right hand side we derived by using Bayes theorem. So in this slide, if you have any doubt, you can unmute and ask me. But still one more step is left for final classification. Now we will see final classifier. So here finally what we have to do is we have to calculate. So P of y given x. So P of y given x that we derived just now. Y can be either C1, C2, etc. So we have to find the probability for C1, C2. C1 let us assume 0.8, C2 is 0.2. So maximum probability is 0.8 and C1 is the final classification. So that how to write mathematically, we can write it as P of C1 given x, comma, P of C2 given x, so on P of CK given x for categorical classification, from which we are finding maximum value, in which we are looking for argument. What is the meaning of argmax? Argmax means we are looking for maximum value which corresponding to which class. This is called max. 0.88 is nothing but max, and argmax is nothing but C1. So the maximum value corresponding to which data point, that is called, or which class, that is called argmax. Try to understand. Max is different, argmax is different. So max means maximum value. For example, if you take, let us assume, so student and marks, I am assuming just for understanding. So students are ABC. We have 3 students ABC, and marks are 50, 70, 40. If someone will ask what is the maximum, so 70 is the maximum marks. If someone will ask, this is nothing but max. If someone will ask what is the argmax, that means the name of the student is nothing but argmax. So B is the argmax. The student who got maximum marks is nothing but argmax. In our case, the probability which we got maximum class, that is nothing but final classification. So that is the difference between max and argmax. In our case, what we are looking for each class probability, and from that we are looking for maximum probability. The maximum probability corresponding to which class, that is called final classifier output, that is called y here. So suppose if C1 probability is more, then argmax means corresponding to class is C1, therefore y equal to C1. The person having COVID positive or the cancer is classified as a C1, like that. That is the final classifier. Y equal to argmax P of CA given x. How to calculate CA given x in the previous slide we derived. I think it's clear. This is called intuition. Now we will see how we are going to apply for real world problems based on that. So how to solve. If any doubt, you can unmute and ask me. So now we started basic probability and we extended conditional probability and we derived Bayes theorem. By using Bayes theorem, we applied to our data set, and finally the classifier can be written as y equal to argmax p of y given x. So y is nothing but c1, c2. So that means final classifier can be written as y equal to argmax. So here whatever it may be, C1, C2, let us assume binary classification. Here P of y given x. So y could be either C1 or C2. So this is a final classifier. So y means C1, C2 or C1, C2, so on Cn. We have to find the maximum probability. After that, we have to look for maximum probability corresponding to which class, and finally we can make it as y equal to C1. So that is the meaning of argmax. I think it's clear. The intuition is clear. Now we will see how we are going to apply to our data set, and based on that, how we are going to go looking for a classification of the given data, maybe various applications. Now this is the basic classification process. So we know Navier-Bayes classifier just now we derived by using the Bayes theorem, and whenever new data if you provide, Navier-Bayes classifier will give the output that is called classic. Suppose here new data means suppose some new patient visited and we collected the symptoms. Let us assume the symptoms are x1, x2, so on, xn like fever, etc. And we have to apply this classifier. We will get class. This person having cancer or this person having non-cancer, like that. Or maybe if we collect some data, we can classify the student class is distinction, the student class is first class, like that we can classify by using classifier. So this is the basic classification process for the given data set, and we know how to find the probabilities for each class by using Navier-Bayes classifier, and based on that we can go for final class. Class is nothing but here output, or we can call it as a label, or we can call it as a supervision. I think it's clear the classification process. Now we will see Navier-Bayes classifier applications. Now we completed two sections. First section we discussed machine learning fundamentals, and second section we discussed basics of probability, and after that we derived Bayes theorem, and based on that we derived Navier-Bayes classifier, and also we know what is classification process for any new data. We have to take new data and we have to apply Bayesian classifier, and you will get output that is called class. So whatever it may be binary classification or categorical classification. So up to here, I think it's clear. Now we will see what are the applications and how to apply Bayesian classifier to the given data set, so that we can understand in detail. So like this, we have to apply to the data set so that we get output. So these things you can understand clearly when you go to the applications with some of the examples for taking data sets. I will show you some of the data sets and how we are going to apply for the Navier-Bayes classifier for class. So we have huge number of applications by using Navier-Bayes classifier. So sorry. So we have huge number of applications of Navier-Bayes classifier. So medical diagnosis, I will show one of the example also by considering one synthetic data set, and email spam filtering. So whenever if we see what is the meaning of medical diagnosis means, so we have to consider the symptoms from the patient, and after that we have to classify he is having fever or he is not having fever, like positive or negative, or maybe cancer, what type of cancer he is having, whether non-cancer or maybe other type of cancer. So like that we can do by using a Navier-Bayes classifier. It's called medical diagnosis. And email spam filtering, and whenever if I receive a mail, in general we used to receive mail every day. Let us assume this is a mail. Some mail will goes to spam folder. You can check it in the left side of the mailbox, and some will go to the ham folder. Ham means inbox. So we can call it as a non-spam, or we can call it as a ham. So ham means non-spam, or we can call it as a simply inbox. So how the Bayesian classifier will help to send the how the Bayesian classifier will help to classify the given mail is spam or not spam or spam. So I will show one of the example also. and IDS, intrusion detection system. Whenever if I receive a data, whether the data, especially this is very important in cyber security application, these two are cyber security applications by using base and classifier. IDS means intrusion detection system. I will explain that also, what is intrusion detection system, how the Navice based classifier will help for detecting the data is good or bad. So this is very important topic in cyber security. So how machine learning is helpful to the cyber security. There we have this intrusion detection system. So this also I'll explain in today's session. And credit card fraud detection, like that we have, and pattern in customer data set, and estimation gas emission, for forensic analysis, like that we have so many other applications also. And OCR, optimal character recognition, like this is related to image analysis application, like that we have so many other applications also. We will discuss few application in detail by considering some of the data sets. Based on that we can understand exactly how we are going to apply base and classifier to the given data set. So simply reading applications, if I'm not showing examples, we can't understand exactly how we are going to apply base and classifier to the given data set. So that's why I will show one or two examples in detail so that we can understand exactly what is happening by using base and classifier to the given data set. So still weather prediction, speech emotion, so many applications we have. This estimating gas emissions. So this is one of the important applications in smart cities. So when I took sessions for artificial intelligence for smart cities, these things also I used to explain. Now we will see one small case study for the application that is called medical diagnosis. So how base and classifier will help to diagnose the given data. So this is the synthetic data. Initially also I have shown this data set. So we have 9 patients, 1, 2, 3, 9 left, first column, and second column is nothing but symptoms or features. We can write it as a X1, X2, X3, so on, Xn. X1 means one future, X2 means other future, like that. So that is the meaning. So, and that is called PHR. We can call it as a patient health record or personal health record. That is the medical term. So that we can write it as a X1, X2, so on, Xn. X1 means fever, X2 means dry cough, X3 means, let us assume, chest pain, like that. So these are the symptoms, or we can call it as a futures. And class also available. Class means this data already, these patients already tested. So that's why we have, so first patient having negative disease, that means COVID-19. Second patient having positive. So based on the symptoms what this patient having, like that this data already we have. Now what we have to do, this is the active patient data. Active patient means new patient. So we can call it as a medical terminology, active patient, or we can call it as a simply for understanding, so new patient. So this patient having chest pain, dry cough, loss of speech, fever, and shortness of breath. So these are the symptoms this patient having, or these are the features this patient having. Now based on these features, we have to classify whether the person having disease or not. So for that, what we have to do, so we have to make a model that is called y equal to f of x, simply for understanding, I'm assuming, based on the data what available, and for in that x value we have to substitute so that we can classify whether the person having positive or negative. How it possible by using Navice based classifier, that we will see now in detailed explanation. Now the problem statement is clear. We have a synthetic data set. I'm assuming synthetic data set, and we have new data that is called patient 10, and I have to go for classification whether the person having disease or not. So this is the meaning. So we have two classes. One is positive or negative. So that means I have to find the probability of class 1, that is positive, given x. X means x1, x2. This probability I have to calculate. And one more probability I have to calculate. Probability of C1 given x. This also I have to calculate. How to calculate this probability? By using Bayesian classifier. So just now we discussed. So P of C1, product of P of xi given C1. So similarly, this also just now we derived P of C2, because we are focusing for the second class, that is a product of P of xi given C2. So these two probabilities we have to calculate by using Bayesian classifier. And this probability, let us assume 0.6, just for understanding, I'm assuming like this. Later, next slide, I will show in detailed explanation. And this probability is 0.2. And out of these two, we are looking for argmax. Max is 0.6 probability. Argmax means which corresponding to the class C1. Hence, we can finally classify the given data class is C1. Let us assume positive or negative, whatever it may be class. So here C1 means positive, I am assuming. So C1 means the given data. Based on that, we can classify the person having positive. So this is the basic idea. So that means we have to calculate for each class probability by using Bayes theorem, and after that we are looking for maximum probability. After that we are looking for argmax, that means maximum probability corresponding to which class, that is the final classification. Now here we can see the detailed explanation. So first we are calculating probability of positive based on all the symptoms what we collected from the patient. So here this formula just now I told you. So probability of y into probability of x given y, x2 given y, x3 given y. Denominator is constant, condition is given constant, positive, positive. So that is the p of y. What is the formula? P of y into p of x given y. This is the Bayes theorem applying to the data set. So x is nothing but x1, x2 futures. After calculating these probabilities, we know how to calculate probabilities. So probability of positive means out of 9 records, 5 patients having positive. That's why 5 by 9. In similar way, we can calculate other probabilities also. And the value for probability of positive is 0.16. In similar way, we have to calculate probability of negative for all the symptoms, and the probability for this is 0. So now out of this maximum probability is 0.16, and which corresponding to which class? Positive. Therefore, we can classify the given data as positive. That means the person having COVID positive. This is the final classification. I think it's clear. Now we see the beauty of this mathematics. So we derived classifier and we are applying to the given data set. Probability of positive given futures, based on that we got 0.16 probability, and probability of negative based on the given futures we got 0 probability, out of which maximum probability is 0.16, which corresponding to the positive class. Hence we can classify the given data is positive. That means the person having COVID positive. So this is one of the simple example by using Bayesian classifier how to classify. So final classification you can see here, argmax of probability of positive, probability of negative, and 0.16 is maximum. Therefore, positive is the classification. So therefore, the patient with ID 10 can be classified as COVID-19 positive. That is the final conclusion by using Bayesian classifier to the given data set of healthcare applications. Now I think it's clear, this simple example or application of classifier with case study type. Similarly, if you take flu virus, here also we have data set headache, runny nose, fever, and here we have class flu or not. So this is X1, this is X2, this is X3, and these are the patient, first patient, second patient, third patient, like that. And this is the data we have. And we have an active patient, he is having headache, he is not having runny nose, he is having fever. We have to classify whether the person having flu or not. So this is the active patient data. Now based on the existing data, we have to classify whether the person having flu or not by using Bayesian classifier. Here also same thing. What we have to do, we have to find probability of flu yes for the given symptoms. Let us assume X. This probability we have to find. Probability of no flu given X. X means symptoms. This probability we have to find. So based on the maximum probability, we can classify whether the person having flu or not. So that is the basic idea of classifier what we done for previous example also. Now we will see the explanation. You can see here. So we have calculated flu no based on the symptoms given, and that is called condition. We got probability 0.03. We have to calculate these probabilities, and probability of flu yes, the probability 0.07. So which is more than the flu no. Means 0.07 for yes, 0.03 for no. So out of this maximum probability is 0.07, which corresponding to which class? Yes. Argmax is nothing but yes. So finally the classification is yes. So finally we classified the given data is flu. That means the person having flu. That is the meaning. Okay, it's clear. Yeah. Now we will move to the one more application with example. I think it's clear. Now we discussed a few. Of course, we have so many other healthcare applications. Just I have shown 2 examples. One is current pandemic scenario example, that is called COVID-19, and one more is flu disease classification by using classifier. Now we will see for cybersecurity application how we are going to apply this Bayesian classifier for cybersecurity application. So this is the base paper or basic idea beyond this intrusion detection system, we can see here Bayesian based intrusion detection system. So that means we are going to apply Bayesian classifier for intrusion detection system, but we don't know what is intrusion detection system. I think most of them don't know about this. Suppose if you know, fine. If you don't know about this, I will explain briefly. Based on that, we can understand why Bayesian classifier is useful for IDS. Now here in this base paper, they given simply like this: P of A given B equal to. But we derived this formula directly by using conditional probability. All those things we already discussed. So this is published in Elsevier journal, Science Direct. Now we will see how we are going to apply Bayesian classifier for intrusion detection system. So before going to that, what is intrusion detection system? Because cyber security is very, very useful for machine learning, artificial intelligence. So why means we have more data and we have to clean data. So many things are there. That's why so we are using artificial intelligence or machine learning model to the cyber security, in which intrusion detection system is one of the application of machine learning. So what is the basic idea of intrusion detection system? I'll explain here. Just I will try to make a empty slide. 1 second. That I will explain, then we will see. I will make one duplicate slide for empty. Yeah. Just a second, it's buffering. Yeah, I think it's clear, visible. So now we should know what is intrusion detection system, how we are applying Bayesian classifier to the intrusion detection system application. I have shown the base paper. What is the meaning of intrusion detection system means? So let us assume this is a network. So let us assume this is a network. So we are receiving, this is the organization. Let us assume here we have organization. So this is the organization. So we are receiving data through packets, whatever data if we take. So this data means, let us assume mails or videos. It may be structured data or unstructured data or semi-structured data. Again, no need to explain what is structured, unstructured, semi-structured. Just assume some data, mails, videos, documents, and some files. So many things we are receiving through network. So this is a through packets. So these are all packets. So packets in terms of zeros and ones, 0, 1, 0, 1, 1, like that. So this is the basic idea. We have a network system and we have organization. Every day we are receiving, not only every second we are receiving huge number of data. It may be mail, files, documents, etc. So whatever data we are receiving, so we don't know whether the data is good or bad. What is the meaning of bad? Any type of attack possibility is there. So bad is nothing but we can call it as a malicious data, or we can call it as any attack. So any attack possibility is there. So it may be virus, or it may be, we have various type of attacks, DOS and various type of password attacks, like that. We have various type of attacks here. Any possible attack possibility is there. So if you don't have any detection system, then there is an issue. So in that case, what we have to do, so intrusion detection system, what it will do, it will monitor the given data continuously. It will monitor the given data. Whenever there is a possibility for the data is bad means malicious data, then immediately it will give alarm. Then administrator will take care of further step. So that is the basic idea of intrusion. Intrusion means unauthorized access. We can call it as an unauthorized access. What is the meaning of intrusion? So intrusion, we can call it as an unauthorized access, or technically speaking, we can call it as a hacker. So there is a huge number of hacking is nowadays possible in most of the organization. That's why we need cyber security concepts or cyber security mechanism, so that we are trying to minimize this type of hackers to attack the organization data or institutional data or university data, etc. So here intrusion is nothing but unauthorized people, or we can call it as a hackers. These hackers can be again classified as a internal hackers, or we can call it as a intruders or external intruders. So internal means inside the organization also we have intruders, that is called hackers. External also possible. Now what the intrusion detection system will do, basically whatever data we are receiving, so this intrusion detection system will monitor if any data received badly or any type of attack possibility is there, then immediately it will give alarm then we can go for further step. Administrator will go for further step. So, but the question is how it will detect. That's the question. We are receiving data in terms of through packets, huge number of data we are receiving. So, how we are going to classify the data is good or bad? We are receiving some data. Let us assume x1, x2, so on, xn. Now, whatever data we receive, we have to classify this data is good. There is no issue. This data is bad. So, immediately bad means here malicious data. That means someone is attacking our organization or someone is sending some virus through our network. So that is the meaning here. So in that case, immediately it will give alarm to the administrator and he will take care. But how Bayesian classifier comes to the picture? So here machine learning models are very, very helpful to classify the data as good or bad, in which Bayesian classifier is very, very useful to classify the data is good or bad. So that's why classifier, that means Bayesian classifier comes to the picture. By using that, we can classify the data is bad or good, or maybe any type of attack also we can classify. We have various type of attacks. So let us assume attacks, or let us assume H1, this is one type of attack, this is one type of attack, let us assume HN. So maybe it will classify the attack is H1, or maybe the attack is H0. H0 means there is no attack. Like that, it will go for categorical classification also. So we have DOS attack, DDoS attack, and password attack, and malware attacks. So many attacks we have. So it will classify, and based on that we can go for further step. So this is a basic idea beyond this intuition detection system. Now how the Bayesian classifier will help to classify the given data is bad or good, or maybe any type of attack. So that is the idea what here. So intuition detection system will helpful to detect the unauthorized access, and it will give immediate alarm to the administrator. Now, how it is helpful, how we are going to apply Bayesian classifier for intuition detection system. So I have shown already one base paper, Bayesian based intuition detection system. So there we can find complete details, but I will show one example here. So this is the data set that is called KDD Cup 99 data set. We can find a complete information or data set attributes meaning in the repository that is called UCI machine learning repository. If anyone doing research on machine learning or data science or deep learning, you can go through this UCI machine learning repository. It is kind of Kaggle GitHub repository only, but here we can find huge number of data sets for any application. Just you can type the application data set, let us assume healthcare data set, or cancer data set, or recommender system data set, or movie data set. Like that, if we type, we can find huge number of data set in this UCI machine learning repository. So from this only I have downloaded this KDD Cup 99 data set for classification of the data is good or bad, the data is normal or maybe abnormal. So you can see here we have various features, or we have attributes. So we have 41 features. It's little bit huge data set. So this is x1, this is x2, x3, so on. And we have one response. Obviously, always we have one responsible, that is called class or output. So you can see label. So label, normal data, whatever data, if we take this row, first row, this row, normal data. Here if we take this data, if we take, let us assume, so this is called Neptune attack, NEPTUNE. This is one type of attack which is related to the web browsers. So so this is the one type of attack, that means abnormal data. If you open this data set, you can find more than 10,000 records, and corresponding labels also you can find. You can apply for your research work or maybe any paper publication. So from the UCI machine learning repository. Now the basic idea is here. So I'm taking two classes, one is normal, one is Neptune. So whatever data is seeing recently or maybe newly data, we have to classify the data is normal or not abnormal. Here also we have one type of attack, you can see. So many type of attacks we have, that is called abnormal data. How to classify? By using Bayesian classifier. So here I'm taking one synthetic data set. You can see here. So serial number. So x1, x2, so on, xn. So first, this is the first record in which the class is normal, and we have second record in which the class is normal. Same thing. Here we can see fourth record. The class is one type of attack, that is called Neptune. This is abnormal. So this is called malicious data or abnormal. We can call it as a malicious, abnormal data. Here also we have one type of attack, that is called Neptune. This is Neptune attack is related to the web browsers, and we have normal, 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 normal. So these are some data class or label is Neptune, some data class is normal. Now we have test instance. So this is the data received just now. Let us assume this is the new data or active data. So I'm assuming X1 to X6. But if we take original data set of query of 99 data set, we have 44 futures and one responsible variable or one class. But that much data set difficult to apply manually. That's why I'm taking a synthetic data set by considering six futures or maybe attributes and corresponding to one responsible variable or one class or one label. And records, I'm assuming 10 just for convenience to write the probabilities. And when you come to the test instance, so this is the active data just now we received. The label we don't know. We have to classify the label, whether the data is normal data or whether the data is not abnormal data. This we have to classify. So by using Bayesian classifier, I think that the data set is clear here. Now whatever data we have, new data, by using that we are going to class the label. So here what we are going to do, one second. Just a second, yeah. So here what we are going to do is we have to calculate probability for normal as well as abnormal. So abnormal means in our data we have a Neptune attack, that is one type of web browser related attack. So for that we have to find both probabilities. So first we have to calculate probability of normal given x. X means that x1, x2, so on, xn. So we have to calculate formula. You can see this already we discussed, and this probabilities we know how to calculate. The probability what I got by using normal class is 24 by some data here, and for Neptune, that means abnormal, I got this probability. So now classifier y equal to argmax, probability of normal given x, Neptune given x, and after that we got maximum probability is 18 by 2430, which corresponding to which class, Neptune type of attack. Therefore final classification is Neptune. That means abnormal data, whatever data we have received, that is abnormal data, hence we can say that there is a type of attack possibility there for our organization data. Immediately we'll go for further step. So this is the way we can classify the given data is normal or abnormal by using Bayesian classifier, what we discussed previously. So this is very, very important in cybersecurity application. So that is called intrusion detection system. You can find n number of research articles on intrusion detection system, but the basic idea what we discussed, our aim is to classify the given data. Still we have so many other methods also for classification that also we can apply, but whichever method will give more accurate result, that we can go for final deploy to the application. I think it's clear. This is in. Now we have one more application that is called email spam filtering. So whenever if you receive email, some mails will goes to the spam folder, some mails will goes to the not spam, or we can call it as inbox. So how to classify? So this is, we have so many mails here. So let us assume this mail is received. Now machine learning model, what machine learning model we are going to apply here? So Bayesian classifier we are going to apply, and based on that we have to classify whether the mail is spam or whether the mail is not spam. So email fraud is cyber terrorism. Actually through email also nowadays there is a huge number of attacks happening because of that reason. So there is a huge demand for this Bayesian classifier or maybe other classifications or classifying the mail is spam or not spam. So that's why machine learning models are very, very important for catching the spam or non-spam mails. So this is the data set. If you are looking for this data set, you can go to Kaggle repository or UCI machine learning repository. There you can download. So the data set not like previous like X1, X2 tabular form. This is in terms of text data. So you can see one example. Ham is not spam. Go until Jurong point. Crazy something is there here. So this is the ham mail what I have received. I'll show one spam mail which is similar to the mails what we are receiving every day. So here somewhere I will show one spam. Something prize, a lottery, you won the prize, you got promotion, please pay, like that. So this type of things comes to the spam folder. So here one example, so many mails we have. Ham, here also we have spam, free entry. So this is one type of spam mail, and you can see here this spam, you can see, you can understand here. So spam winner, this type of mails frequently we used to receive. Winner, you have to pay $900 immediately and you will win 2 lakhs or maybe 2 crores money. Like that we used to receive. This is spam. Here the keywords like winner, lottery, prize and promoted, this type of keywords, whenever it is happening in the mail, it will automatically classify to the spam folder. So here winner, you can see here. So you selected and you will receive 9,000 pounds prize money. And also please call to this number, again they will ask some money, or please deposit to Paytm, PhonePe, like that they will ask. So this type of mails are spam mails. Automatically it will go to the spam folder. How it possible? How the Bayesian classifier will help to send these mails to the spam folder? Even here also you can see some of the messages. So here you can see one text message. Congratulations, you are selected. This is a spam, not spam. Congrats, you won the lottery. This is spam. This is also one simple data set for better understanding I'm taking. And travel for free. So this is also spam. And selected for credit card. This type of mails we are receiving nowadays frequently. So click this link and enter your credit card details. This is one type of attacking your credit card. So fraud. So this is also spam. And very good, no issue. Good night, no issue. And lottery. When you find this text, obviously it will go to spam folder. So this type of data we have already, and we know class also, there is category also we know. Suppose we have a text message, you won lottery. So how to find whether the mail is spam or not spam? So I have received a mail in which we have a sentence, you won lottery. So for that, what we have to do is, we have to find by using Bayesian classifier, we have of spam given, so x1, x2, x3. So x1 is nothing but the words in the sentence. We can't directly apply sentence here. This is x1, this is x2, this is x3. Like that, we can separate the entire word as a single. I mean, entire sentence as a single word. x1, x2, x like this. So spam probability we have to find. I'll show in the next slide. So this probability is, let us assume 0.6. And probability of non-spam, let us assume ham, we can call it as a ham, HAM. So for that, x1, x3, you won, that means x1, x3. So this probability is, let us assume 0.9. So 0.9, so sorry, 0.3 I'm assuming, let us assume. So ham is 0.3, spam is 0.6. Therefore, the mail what you have received, it will go to the spam folder. So this is the basic idea beyond this by using Bayesian classifier. We have to find the probability for spam given whatever sentence. We have to find the probability for ham, or we can call it as a non-spam, whatever sentence we have received, and we have to look for maximum probability, and maximum probability corresponding to the class that is called spam. That is the final classification. So that means here if I type a text, let us assume you won lottery, the classification is spam. This is the final conclusion. So by using Bayesian classifier, we have classified the whatever mail we received, which is having the sentence you won, that it will goes to the spam folder. So this is a idea beyond this classification of spam or not spam by using Bayesian classifier. So this is the idea here. So spam and a lottery, and we have to find these how to find the probabilities, and maximum probability class is the final one. That is the conclusion. Here I am giving explanation. So we have to find the probability for each sentence. After that, we can classify. So the complete details you can find this spam or not spam from this web, journals, machine learning for email, spam filtering, review approaches, open research problems, all those things you can find from this journal, from this paper. You will get more idea because I'm giving basic idea. So just a second, it's buffering. Yeah. So the complete details you can find here, how the machine learning models will help for email spam filtering, including Bayesian classifier, maybe other classifiers like SVM, support vector mission, decision tree, random forest, maybe other algorithms. We can find complete information in this publication. If you are looking for spam filtering research work, even here also. So proposed efficient algorithm for filtering spam using machine learning techniques. This is also science direct paper. Now it's clear. So Bayesian classifier we know, and we know how to apply for the medical data set. We know how to apply for intrusion detection system in cyber security application, and we know for application of spam filtering how to classify the mail is spam or not by using Bayesian classifier. So it's fine, everything is fine. So we have applied Bayesian classifier for various applications with considering some of the data sets. So we can call it as a case studies. Now, how to evaluate? So, because I already said, whenever if I go for, let us assume, so we have a data set. So, we have a data set here that is a structured data set and labeled data set, and we have to apply some model, some machine learning model. Then it will make a machine learning algorithm we have to apply, and it will make a model. And we have to apply test data for testing whether the mail is from any new mail if we receive, we have to go for so test data up to here clear, and we got here output. So whether the mail is spam or not spam, or maybe the given data having any type of attack like intrusion detection system, or whether the features what we collected from the patient positive or negative, like that. Up to here it's fine. So everything we done. Data set we have, we know machine learning algorithm, and we know how to apply for the test data, and we know what is the class based on the Bayesian classifier. Now, what is the final step? So we have to go for evaluation. That is very, very important. Initially also when I explained machine learning model, I said after test data, we have to go for evaluate. Why we have to evaluate? Because we have so many machine learning models are available. So after getting output, I can't say Bayesian classifier is the best and we can deploy to the application. So we have to evaluate, we have to see the accuracy. Based on that accuracy, we can deploy to the application. If accuracy is very good, fine. If accuracy is very less, immediately we can try to look for any other alternative machine learning model, or maybe hybrid machine learning model. Then we have to see the accuracy. If that accuracy is very good, we can deploy to the application. It may be healthcare sector, or it may be any other sector we can deploy. Otherwise, we have to redo the work. So we have to apply various algorithms, and finally we have to find. Now the question is how to evaluate here. So evaluation measure. So for that we have one simple evaluation measure by using confusion matrix. We will see it's very simple concept. So of course the name itself it will make you confusion for this confusion matrix. So by using confusion matrix we can evaluate. So what is the confusion matrix? So it's a 2x2 matrix for binary data, or it may be more than that if you go for categorical data. So let us assume here, so this is the actual data, let us assume, so I'll put underline here. So this is the actual data, this is the predicted data. So actual data, let us assume, I'm assuming 1, 0, 1 means positive, 0 means negative, let us assume. 1 0, let us assume like this, sorry, here 0. So 1 1, so this is called true positive. So that means what is the meaning of true positive? So actual data is COVID positive, and my model also, that means classifier also detected as a COVID positive. So this is called true positive, TP. I think it's understood, TP. Next, so actual data is negative. Actual data is a positive, let us assume, but my model predicted as a negative. So this is called false negative. Here you can see false negative. So actual data is 1, but my model predicted 0. Instead of COVID positive, my model predicted as negative. That's why false negative. Next, coming to second column. So actual data is negative, but the model is predicted positive. That is called false positive. What is that mean, false positive? Actual data is negative, but my model predicted as the person having COVID positive. So that is called false positive. Next, actual data is negative, my model also predicted negative. That's why this is called true negative, TN. So these terms little bit confusing, don't worry. That's why I'm giving example. So negative, negative. The method also detected as a negative. This is called true negative. This is called confusion matrix. So once again, you can see the terms. So actual data 1, 0, 1 means positive, 0 means negative. Predicted data, that means the model what I have applied to the given test data, that means based in classifier. So 1, 0. So TP means true positive. So that means actual data is the person having COVID positive and the model also predicted as a COVID positive. Next, false negative. The person having COVID positive, but my model is predicted as a COVID negative. That's why false negative. Next, false positive. The person having COVID negative, but the model is predicted as a COVID positive. Next, true negative. The person having COVID negative, the model also predicted as a COVID negative. So this is the meaning of TP, FP, FN, TN. Now, what is the accuracy? So the accuracy, of course, we have sensitivity, specificity, true positive rate, false positive rate. So many measures are there. No need to worry about all those things now. You can, in free time, you can refer. Just I am showing how to calculate accuracy. So accuracy is nothing but here. So true positive, because we are looking for true only, true positive plus true negative, that means diagonal, divided by sum of all values. So true positive plus true negative plus false positive plus so on. So sum of all the entries is nothing but denominator, sum of principal diagonal is nothing but numerator. That is called accuracy. Suppose if accuracy is 0.98, let us assume, so 98% the model is accurate. If the accuracy is, let us assume 0.660% accurate. That is the meaning here. So we have to evaluate and we have to calculate the accuracy. Based on that, we have to see whether the model is fit to the given application or maybe domain. If it is very good accuracy, we can go ahead. So if we take one small data here, let us assume. So let us assume here actual, this is predicted 1, 0, 1, 0. So I'm taking 10 samples. So 10 samples I'm taking. 10 samples positive data and 10 samples negative data. That means COVID positive COVID. So actual 1 and predicted also 1, let us assume 9. And actual 1 predicted as negative 1, 9 1. Here 2, 8. Actual is negative, but model is predicted positive. Actual is negative, model also predicted negative, 8. So this is the confusion matrix for 20 samples. What is the accuracy? A equal to diagonal sum, 9 plus 8 divided by sum of all values, 20. That means, so 70 divided by 20. So this is the final accuracy. So here around we are getting 88% approximately, 88% or 90 approximately. So we are getting around 85 or 88, let us assume 88 approximately. So this is the accuracy of the given model. So always we have to evaluate the model, then only we can make a conclusion. If accuracy is too worst, then how can you deploy it to the application? So this is a way to evaluate the given model. And here I will show some of the resources. If you are looking for further enhancement of this machine learning by using various mathematical models, you can see machine learning for mathematics. So you can download even from Google, or you can you can buy also through Amazon or Flipkart. And one more, mathematics for machine learning. So this you can download from Google, only available. Soft copy is available. You can refer. That is very, very important. Why means I'm showing this? Without mathematics, there is no use of studying machine learning, deep learning, data science, artificial intelligence, natural language processing. So mathematics is very, very, very important for all the latest emerging trends. So wherever if you go, if you are not able to understand mathematical formula and you are trying to apply, there is no use. How to make the data into product without understanding proper mathematics? So that's why mathematics is very, very important for all the machine learning, data science algorithms. That's the intuition I given. And mathematics for deep learning, here you can find there is a lot of mathematics for deep learning, because in deep learning models we have huge mathematics. So you can find very interesting mathematics in this textbook, and you can download this textbook from the Google also, free of cost only. It's very simple textbook, maybe around 150 pages only. So that was my talk. If you have any queries, you can unmute and ask me. We discussed machine learning basics, we discussed probability, we discussed Bayes theorem, we discussed Bayesian classifier, we discussed applications, we discussed how to apply Bayesian classifier for email spam filtering, healthcare data, and intrusion detection system. Even we covered cyber security concept also, and we discussed how to evaluate the given models by using a confusion matrix. So if you have any queries, you can unmute and ask me. I'm happy to answer.
Good afternoon, sir.
Good afternoon, madam.
Very nice presentation, sir. Session
Thank you,
was
madam.
really informative and
Thank you.
useful. Sir, I have a question, sir. We
Yep.
have a lot of classifier algorithms. Why
Yes,
we go
ma'am.
for naive-based
No,
algorithms?
no, no. Initial I said, so we can't say this is the classifier. It may be Navi based, it may be support vector mission, it may be a decision tree, it may be random forest, it may be KNN. We have huge number of classifiers. So what
Yes.
we have to do, we have to apply these classifiers to the given data set, and we have to evaluate which classifier is the best. Suppose some classifiers may be best fit to the some data sets. Some classifier may be best fit to the other data set. That's why there is no statement like that Bayesian classifier is the best or KNN is the best. We have to apply all classifiers and we have to look for the accuracy. That's why I given end of the session accuracy, how to evaluate by using simple confusion matrix. And based on the accuracy, we can decide this is the classifier for suitable for that data set. So that's why we can't fix any classifier is best for any data set, madam. Or you can go for hybrid also. If accuracy, if you are not able to satisfy, then you can mix some classifiers and you can apply to the given data set. So I'm not able to. I did not made any statement like that. Bayesian classifier is the best. This is one of the classifier. By using that, we can do classification, madam. But this is also very important classifier when compared to other classifiers. But some data set this may be worst classifier. Maybe some data set maybe this is the best classifier.
Okay, sir.
I
Okay.
think is it clear, madam?
Yes, sir. Thank you,
Yeah.
sir. Thank you so much.
Any other queries, or you can type your query in the chat box. I will see that also. So we have a chat box. You can type in the chat box. I'm happy to answer.
Participants, please respond. If you have any questions, please ask.
Yeah. Shailaja Ganesh, thank you, madam, for compliments. Yeah, fine. Thank you.
Excuse me, sir.
Yeah. Madam, tell me, madam.
Can I have the names of those research papers you mentioned?
Yes, sure, madam.
Three
Sure,
research
madam.
papers.
Yes, madam. Sure, madam. I will
Yeah,
share, madam.
thank you.
I will share to the organizers, then you can collect from them, madam. Not an issue.
Okay, thank you, sir. Thanks.
Yeah, welcome. Any other queries, you can type in the chat box also fine, or you can unmute and ask me. I'm happy to answer.
Sir, please share your mail ID also in the chat box.
Yeah, I will share, sir.
Participants can note the email ID. If you have any
queries, you can send
queries, you
to
can
this mail I have shared in the
contact
chat
later
box.
also.
Because I have covered so many things: mathematics, cyber security, machine learning, probability. So that's why nowadays data science, all these are interdisciplinary. I can't say it's a computer, I can't say it's a mathematics, I can't say it's a probability. It's interdisciplinary. So most of the universities, even mathematics department also offering data science. Some of that
Yes. Yes, sir. Mathematics department also offering.
yes. Even statistics also. If you take a University of Coimbatore, I gave talks there also. Statistics department offering data science.
Yes, here also mathematics department planning to start.
Yeah, it's good, sir. Mathematical people,
Data
mathematics
science.
background people can give more justice. Of course, we need programming also for implementation, either Python or R program.
Yes, yes. I hope it is clear to everybody
Yeah,
about
thanks.
this Navi-based classifiers are given an in-depth an in-depth knowledge about the Navi-based classifier, and sir also explained. Yes, any queries?
Yes, sir. So, one
Tell
query
me,
from my side.
Swati Goyal. Yeah.
Swati Goel. Good afternoon, sir.
Good
Oh, good
afternoon.
afternoon.
Sir, actually, I just want to ask, can we apply this theorem on the WSN for the routing protocols or the analysis of the routing
You
protocols?
are asking related to networking now, madam.
Yes, sir.
How to networking, I'm not sure. Of course, maybe possibility is there, but we have to check, madam. Because networking protocols that so far I did not apply to the data. But we can try, madam. What will ASN classify to our question?
So, actually, the data set you are asking about to check from the UPA,
Yeah,
I
yeah.
checked over there, but I didn't get any data set regarding the routing protocols.
Otherwise, maybe you can check it in other repository like Google or GitHub, madam. Surely we'll get somewhere.
Okay, sir.
I will check it, madam. Madam, I provided mail ID. Just you can send that information. I will also try, madam.
Okay,
So
sir.
that even
Yeah, sure, sir, sure.
For me also useful in future, so that I can also apply for any publication.
Yeah, sure, sir. Okay. So I will mail you, no?
Sure, sure. That's why my FDPs are very, very useful. Just we are sharing knowledge. I can share and I can get inputs from the participants also. Even I can also grow.
Yeah. So actually, that is the main benefit of attending the workshops.
Thank you. Yes, man. Correct, correct. What is it? Correct.
Okay, so thank you.
Thank you, man. Thank you, man.
Yes, it's a very good discussion.
So,
FDPs are for sharing the knowledge.
Thank you, sir. Thank you for opportunity, sir.
Yes, sir. Yes, yes.
excuse me, sir.
Yes.
Madam, tell me, madam.
Sir, I just need a help. In case I want to work in IDS,
Yes,
what
madam.
another technologies I want to learn before going to that research?
Intrusion detection system, madam.
Yes.
Yeah, no, first we should know the basics of networks, man, computer networks. Because what happens in intrusion detection system, we have various attributes. We should know what is the meaning of each attributes. Because even I'm not expert in computer networks, but we should know before applying intrusion detection system algorithms, then we can apply directly machine learning algorithms, madam. Only basic option: what is intrusion detection system, what are the types of attacks, and what is the meaning of each attribute. You can find these details in USA machine learning repository. They explained 43 features, meaning each and everything. And also we should know cyber security fundamentals also, why we have to apply cyber security, what is it, cyber crime, all those things we should know. Basic option, madam.
Okay. Thank you, sir.
Even we have so many papers available in various publishers. So intrusion detection system by using machine learning models. You can type in Google, you can find, madam.
That's fine. Actually, I stuck my research at,
Yes.
I have identified the parameters on which I have to work on.
Okay,
Where
okay,
I
madam.
stuck is that at that time Python was not there. So that's why I'm asking for, okay, is there any built-in tool on which we can go
Okay,
for
okay,
these
understood, understood.
parameters?
Yeah, we have to check, madam. Built-in tool means we have to check any, maybe some Vika software. Can you check, madam? WKA, Vika software, something is there. You can try, madam, that one.
Weka. WEKA.
Yeah, yeah, WK,
Weka.
Vika, yeah. There are
Thank
so
you, sir.
many classifiers are inbuilt. Just if you
Yes,
apply
yes.
data, you will get output.
No, that is a GUI. No need to
Yes, sir.
write any
Correct.
code.
Correct, sir.
It's good for non-computer science students.
Yeah, yeah. But we should know how it will work. That is important.
Okay. Thank you,
Yes.
sir. Thanks a lot.
Thank you, madam.
Okay.
Thank you.
Any more questions, please? SAR covered a Navy-based classifier in depth and also explained through the some data sets, healthcare data sets, and KDD intrusion detection data sets, and spam mail classification. Uh, Explained very clearly, and also explained various methods or various terms of the classification, like how to calculate the accuracy of the classification through the confusion matrix. I hope everybody enjoyed and learned so much from this session. In further also, if you have any doubts, you can contact the sirs or given a mail in the chat box.
Yeah,
Thank
one
you.
more session is there at that time
Yeah,
also.
yeah. And sir will also join one more session on the Friday so that we can meet one more time, sir. Thank you, sir. Thank you very much
Welcome,
from
madam.
Department
Welcome,
of
sir.
Computer
Welcome, sir.
Science. We'll meet again, sir, on Friday.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you
Thank
very
you all.
much.
Thank you all.
Okay.
Thank you.
Okay. Thank you, participants, and we'll meet at 2:30 for the today's third session. Okay. Thank you all. Thank you, sir. And we are sharing the materials and PPT, whatever we have, through the group mail and through the WhatsApp. And people are still asking to share it. Individual sharing is not possible. So whoever is in the group and whoever is in the Google group and whoever is in the WhatsApp group only can get the material. Okay. So everybody must join in the groups. We already added group in group, but some mail IDs and some phone numbers are not working well, so that they are not joined. If you anybody not joined in the groups, please inform to our scholar Manas Rahman so that he will add to you. Okay, thank you all the participants.
And
We will meet again after lunch. Manas, anything else?
sir, the yesterday's recordings already shared both
Yes,
in
yes.
WhatsApp and Google Groups. Okay.
Okay. Yesterday, recorded videos also, links of the recorded videos also shared through the group mail. And the full video is not possible to share immediately after workshop only, after FDP only. Full video or YouTube links of the video will be shared after the workshop. We will upload these videos on the YouTube and YouTube links will be shared. You can also download from the YouTube that time if you want. Okay. Thank you all. We'll meet again at 2:30 in the third session.